Cool. So today we're gonna, I guess we've done a lot of this connection and stuff. Today we're gonna do something a little bit different. I haven't sent you guys this notes, but I was scavenging the internet for like very important things as an SRE, right? And these are like huge SRE interview preparation guide, like going through all of these steps, the whole Linux process, file system, kernel, networking. We'll call it networking, but this is more networking, right? We're going to cover containers, Kubernetes. So you can consider this as the curriculum for the class. We're not going to do everything. You can see here the three clouds, AWS cloud, Azure, and GCP. You can use this as an additional learning on your own, but we are going to go, we have done most of these things already, like simple things. What happens when you type in CNN.com in your browser, right? We've done that. See that? That's basic, right? They explain it here. This is it. That's an interview question on its own, right? And then what happens when you google.com in your browser address box, right? In Linux, Linux and all that stuff, basics. So these are things that you can use to prepare for a site reliability engineer interview. Straightforward. So I'm going to give you guys all these links, right? And another one that I wanted us to focus on today, these are books if you care about books, but this particular one is very important. This is the performance checklist. Whenever an application is going through on performance issues, this is where you will check these things, these top 10 commands, this for disk issues, these top 9 commands, and for networking, these top 10 commands, and then for CPU, these commands. That's it. That's it. Done. So in an interview, they ask you, what would you check? If it's a network issue, this is what you do. Done. Straight. All that reading of many notes and things, no. Focus on this and answer the interview question, pass it, get the job done, right? So I wanted us to create a little bit of a small PHP application today. And then from there, we're able to run some of these commands to see the uptime and really dive a little bit deeper. Okay. So if I go on this diagram, if I go on this Lucid chart right here, what we're going to create is something like this. We're going to connect to a server. And on this server, we're going to create the following things. We're going to create a web server. We're going to create an application. We're going to create a web server. We're going to create an app server, an app service, sorry, a web service, and then a database service. All within this one application. These three things will be running here. And then you'll be able to connect clients, which is this client will be Firefox, right? You'll be able to log in. You provide your username and password, right? And you'll log in. So these are the steps. You don't have to do it. You can just watch or do it. These are the steps, right? All the way down here, right? It's a very basic PHP application that you're going to see if you don't see this. I want to connect to this, okay? So I'm going to create a brand new EC2 instance or a brand new server, and I want to go through all these steps. We're going to do this, and then I resolve my Google issue. Oh, I didn't resolve it yet, but I have this Google account. I'm going to show you how to create a virtual server with Google as well. And then I think we'll wrap up class. Okay? That sounds like a plan. So if you haven't subscribed to this channel, this is the channel. I made the videos public. Sorry, this is the playlist, but this is the channel. If you haven't subscribed already, subscribe. The videos are now public. I'm gonna put the share and put in the chat one more time. I don't know gonna do private, so it's public. So, right. You can just subscribe and every time you. So today we'll be doing class 4. Today, sorry, class 5. Today will be class 5. We're done class 1, 2, 3, 4. Today's going to be class 5. Okay. All right. Any questions before we begin? Any questions before we begin, guys? So we are doing we are doing we've done a lot of networking, right? Are there any questions for networking? No? Okay. Let's do some projects then. So we're gonna go to EC2 here. I need to delete this one that's running. I don't know why. Terminate this cluster. Were you guys able to download mobile extend? Yes. Anyone download mobile extend?
Yep, I did.
Okay, cool. I hope you did because it's very important, right? You need to use some tools to connect. So let's create an EC2 instance. Let's refresh this. If my connection is breaking, please let me know, okay? Please let me know. So we're gonna build a uh, LAMP server application. That's the name of it. Is this best practice? Is this best practice like this? Yes or no?
No.
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 What should I do?
You should add underscore
Thank you.
server application underscore.
Okay. Because we're creating a little application, I don't want to just have one CPU and one memory, right? I want to scale up a little bit. Okay, my connection is not acting up. So I'm gonna go to, guys, give me 1 second. I'm gonna go to the living room where is it better now or am I still breaking up? Is it better?
Yeah, it's better.
Okay, hey, I was breaking up and I realized it. Right. So I'm gonna choose I'm gonna choose a higher class just because we're gonna do a lot of installation on this server. So I want something like a bit bigger. Probably do a T2 medium. So T2 medium has 2 virtual CPUs and 4 gigs of memory, right? So I'm gonna do a T2 medium. So I'm just gonna reuse probably create a new key pair called a lamp. I'm just gonna create that key pair, and that's it. And then here, want to assign, I want to do some additional networking. Auto IP and I'm gonna use an existing security group, like probably like or is it 24, 25, 26. And I want to do a public subnet. Okay. And I want to add some space. Instead of 8 gigabytes, I want to do 20 gigabytes. Okay. So that's it. You can look at some advanced details and everything's normal. on my launch instance. So here's this right here. We may have to do all this comparing it to instances. So this is the one. Okay, so here are the steps. So once the server is done, we're gonna go ahead and put the LAMP server. So these steps are to install. This is to upgrade the server, right? Sudo DNF upgrade -y. This -y right here says that for everything that we need to install, just hit yes. If we omit this Y, right, it's gonna ask us, do you want to continue? Yes or no. So if we just put -y here, it will just go yes, yes for everything. And then we're gonna install the latest version of Apache web server. So there are two types of web servers in the world, right? Actually, three. So types of web servers. A web server is what runs is the system that runs a website. Let me put it that way, right? You have Apache web servers. So it's owned by the Apache Foundation. Apache Foundation is a huge foundation that created many, many projects. They have a lot of projects that it creates, open source projects. These are all the Apache projects that exist in the world, and many, many of them. Huge, many, many of them, right? Hadoop, Kafka, a lot of things. So the Apache web server is one of these projects, open source. Nobody owns it. Nobody, it's just a group of people that manage it every day, right? People wrote code about it. That's it. So we're going to use Apache web because it's free. The other ones that exist, you have Microsoft IIS. It's not free. Obviously, Microsoft sells everything. Everything is Microsoft licensing. It's not free. And then you have Nginx. Nginx can be free, depends on the version you have. They have a free version and they have an enterprise version. So those are the three web servers that exist. Okay. So for the web server, this is what we're doing, right? So pretty much you can say in the web layer, if we're in the real world, this will be the web layer, right? And then for the app layer, it's simply a PHP application, right? PHP. This is the app layer. And for the app layer, we're doing the type of application. In this particular case, we're going to do is a PHP application. PHP is a programming language that is used to build applications. You don't have to write PHP code, but we're going to just use the PHP code that is given us in here, right here. This is the code, just one line of code. That's it. This is it. This is the whole line of code that we're going to use. That's it. That's the one line. So this is the PHP file we're going to create in the Apache document roots. And that's it. And then for the database layer, we are using the type of database that we're using. In this case, type of database. It's a Maria database, MariaDB. Maria database. It's called Maria database. The reason why I'm giving this is because in the interview, they'll ask you that, okay, have you ever worked with a 3-tier application, right? 3-tier web application. They'll ask you this question, right? And your answer is yes, I've worked in a 3-tier application. They'll like, okay, at the web layer, what did you create? What did you use? So an Apache web server, okay, at the application layer, what have you worked with? You say a PHP application or a Java application or Python application. For the database, what do you use to say MariaDB or the database? Which we're going to see more databases and more application types, right? This is just one of them, right? Amazon.com uses Java. So Amazon.com is a Java application and they have an Oracle database. So users will connect to the web layer and then traffic will go down to application layer, and then from there we'll go down to database layer. Database layer sends a response to the app layer, right? This is request coming down. And this is response going back up, right? Database response to the application response to the web layer, right? Response. And the web layer sends its requests to the application. And then you have, Isabel out here connecting from here to, you can say www.activetarget.com. So we should make a connection from here to here. This website lives on this server, right? It's the same thing, like that. Like that. And then that's how it goes. The request comes down from the web layer to the app layer to the database layer, and then the database responds back to the application layer, and application layer responds to the web layer. Quick question. How do these servers talk to each other? If these are servers, how do they talk to each other? These servers, this server, this server, this server, how do they talk to each other?
Through private IP address.
Over what protocol?
BGP.
Thank you. Okay, cool. Let's see. Our instance is done creating. So this is what we're going to create. This is what we're creating. This is the little architecture we're creating. Okay. So instead of having 3 separate servers, we're putting all 3 on one server. Right? We're putting all 3 on one server. The web application and database will be all on one server because it's a small, light application. In the real world, you will not put it all on one server. You will have the web on its own server, application on its own server, database on its own server. Okay? Something like that. But this is the same explanation, the same thing. It's the same with that request flow. So even though under the same server, it will still go from the web layer to the app layer and everything. But it's all within the same server, which we will see. So here's the EC2 instance. One thing is strange. Okay, here is a public DNS thing that we're going to use. Okay, cool. I couldn't find in the pickup, and this one has it. The other instance that has it didn't have this. Okay, cool. Let's go. So first things first, security-wise, we want to make sure that this has HTTP and HTTPS, because users connect to applications using HTTP like that, right? That's how users connect to applications. They're not going to connect to the IP address. They don't know what the IP address is. So when we're done creating our application, we're going to connect using, you guessed it, where is it? Details. We're going to connect using this name, this domain name, this DNS name here, right? This is what we're going to use as our domain name, not numbers. I'll give you guys the link. You'll be able to go and log in and try it out and everything. Then we're going to crash it and we're going to troubleshoot it. That's what SREs do. You troubleshoot things that crash. Hopefully we'll have enough time. So let's begin. Okay, cool. So first things first. And if you want to do this on your own and practice, it's cool, right? I mean, this is what the DevOps engineer will do, right? When they finish building the application and it's up and running like this, all you do is monitor it. People will go log in and log out, will do whatever. You just monitor it. If it crash, then you have to go fix it or troubleshoot it. So it's good to know how to build it. You don't have to do it. It's optional. If you want to do it, it's up to you, right? But I'll advise that you build it. It's like a mechanic fixing the car that he didn't fix. He didn't create the car. He didn't manufacture the car, right? No mechanic has ever manufactured a Mercedes-Benz, but are able to fix Mercedes-Benz. How did they do it, right? So, instances. Okay, so LAMP server application. I'm gonna connect to it using Instance Connect is the browser. However, if I want to connect using an SSH client, I can connect using my SSH client. I'm on MacBook. I have this Mac terminal. I can connect to my Mac terminal. If you have a mobile XTEM, you can do the same thing with mobile XTEM. You can connect to mobile XTEM. How? By running these steps here. locate your private key file, use it to launch the instance. These are the steps. Mobile extend. But we want to stick to the browser for right now. On the job, you will connect using SSH client. Most of the times, not Instance Connect. Take note of that. On the job, you're not going to connect to, you may not even have access to the AWS console like this on the job. You're going to have access to just this kind of client, something like this, and be able to connect. That's it. Okay? So don't get too comfortable with this instant connect. It's not going to always be available. Establishing connection. What is happening right now? When it's doing that, what's happening?
It's booting.
$5. If someone can tell me, I just click on connect right now from here. I clicked on connect and it opened up a new page like this. Someone tell me when you're going back to our client server relationship. Someone can tell me what's happening right now. I'll give you $5.
Session.
Authentication.
Is that how you answer questions in the interview?
The server is trying to verify the credentials of the person who is logging in.
Next. It's good. It's a good answer. It's just it's $5 online. I cannot just give you $5 for a half answer.
Okay.
Pastor, go ahead. I think you know the answer.
Connect. When you connect, you start to. If there is a connection, so the session started.
No. I just came here and I clicked on connect. This is my browser, right? This is my client. Firefox is my client. I want to connect to the server and I click on connect. What happens? What happened, guys? Come on now.
The thing is authenticating, verifying the credentials, and then finally going to connect.
Everything. Do we study? Did anybody study today? Do we study 1 hour a day? Anybody study at all?
Is it looking for the domain name and the route?
So you'll be asking the interviewer the question. Do we study? Do we know anything about clients, server?
Okay. I think by doing this, you connect over internet now.
Come on.
I think the server is trying to send a response to the client.
Very close. Very close. There's another word.
Make a connection.
Very, very close. When you come here, you click on connect and you click connect. What happens?
You send a request.
Who sends a request?
You.
Who? Me.
Client.
The client sends a request to the server and the server responds with establishing connection and opens this up. That's it. Come on, guys. We've talked about this 100 times. I am the client here. You have to use the IT terminal. The client is Firefox. Is the client. So when you click on connect, when you click connect right here, click on the word connect, and you click this connect button right this button behind this button. Let's see if I can see like this frame. No, I don't want to go to there's a code behind this button. There's a code behind this button. There's code. If you click this connect, it sends a request to AWS servers in Virginia, requesting to connect. AWS server now is accepting the connection and is establishing the connection. So AWS server has sent a response back to Firefox, and that's how we're able to see this. Guys, it was talked about 100 times. Please don't forget. When you click on connect, you are sending a request to the AWS servers to connect. The servers will send a response back to you. And when the response comes, you will see that you're connected to your server. I've talked about it 100 times. Use the word client, send a request to a server, and the server sends a response back to the client, and the client is able to connect to the server. Now that I'm connected to the server, I type a command like this, sudo yum update, and I send to the server, and I get this response back. What have I started?
A session.
Thank you. A session. A session has started. You guys are not studying. You're not studying. You don't study, guys. You're not studying. I guarantee you're not studying. Okay, let's create a LAMP server. What does LAMP stand for? What does LAMP stand for? Linux, Apache, MariaDB, PHP. Okay. This will all come in an interview. This will all be an interview. This is a server. And this server is where? It's in North Virginia. And where am I? I'm in Dallas. And this is what? The internet. What did I give this server to connect to it? What did I give it to connect to it? The key pair. LAMP key pair is my credentials. Is the what? Is my credential, this key pair here. So while trying to connect, I sent him what? Key pair. He verified the key pair, and then he what? So this is a request that I sent. And what did the server do? What did the server do after I sent the request and the key pair? What did he do? What did the server do?
The server receives the request, authenticate, verify your credentials, and then respond back to the client.
Perfect answer. For free. Responded back to the client. Response. Whenever there's a request, there's always a response. Whenever there's a request, there's always a response. If you ask, you shall receive. Whenever there's a request, there's a response. If you send a request to a server, you don't get a response, your request was denied or it failed. Whenever you send a request to a server, I don't get a response back, it's an error or it failed. For example, I'm going to type some jargons. Command not found. Failed. Okay. All right, let's install the server. So this LAMP stands for Linux, Apache, MariaDB, and PHP. Right? So we're building the LAMP server here. This is a LAMP. LAMP. Linux, Apache, web server, right? Maria database, and PHP. That's what the LAMP means. So called a LAMP. Okay. Cool. So let's do the installation. So I'm going to just copy this command and paste. I'm not going to type them in, right? If you want to type it in, it's up to you. Nothing to the server is already updated, so it's not gonna run any update. So next thing, we're gonna copy all these commands. This command is installing the latest versions of Apache. This is Apache web server, HTTPD. This is the wget. This is what is used to download packages from the internet. This is the PHP dependency. This is the PHP connection to the MySQL database. This one is a PHP JSON. And then this is PHP itself. And this is the PHP dependencies as well. So I'm going to copy all of that and paste it in here. You can see it's going to install. This is how you install multiple packages in the server at once. You do a sudo dnf install -y, then you do Apache, wget, PHP, PHP MySQL, PHP JSON, PHP, and then PHP development. So this is for use for PHP development. So when they say you should build a server for developers, for PHP developers, you will do something similar like this, right? This package enables PHP developers to log into this server and develop a PHP application. So I'm going to run enter. It's going to take a while, and you're going to install all these things. While it's installing these things, it's consuming CPU, it's consuming memory, because again, it's using memory and CPU. You can see it's installing the PHP 8.3. These are all called dependencies and libraries. This is the prerequisites before we can now build a platform where developers can come and start building applications. All these things are installing on our behalf. So this is the job of a DevOps engineer, right? He builds the servers and hands over to developers to develop applications, and then when they're done, someone has to monitor it and keep the lights on, which is you. So this is the first step before developers even can start building and start coding. This is the pre-steps before coding is involved. Cool. It's done. So we're gonna go to the next step. It's very easy. Just copy and paste. It really, it's not really that hard. So install the MariaDB software package. Use the generic install command to install multiple software packages and all depends at the same time. So you can just copy this as well and just paste it in here. And you hit yes. And it's gonna install the connector and all these other things. Installing. Done. We go to the next step. You can view the current version of this packages using the following command. So all of the commands in green you have to run, right? I just wanted as an extra way to show you guys that you can install everything that regarding MariaDB at the same time. So that's it. It's done. Now we'll have to start the Apache web server. This is a command that you may run. As an SRE, you may run this command a lot. If you are contacted that, oh, the web server is down, you may come up and the first thing you have to check is to see if this is running, right? If the web server is running. So if it's not, right now it's not running, right? Because we just installed it. So the command to run to start up an Apache web server is sudo systemctl start HPD. It's something that you run a lot. If a server crash because of some process or some CPU shortage or whatever, when you come online, you may have to run this command to start the server. Because without a server, users cannot see any websites. Okay. So you're gonna clear your screen. You're gonna run this. It started. So when it started, how do we know it's running? Sudo system ctl status httpd status. That's it. It's running. It's actively running. It's running under this process ID 35877. Why does this Apache server that is running, why does it have a process ID? Based on your knowledge that you know about Linux, what does it have a process ID? Anyone want to take a try? No answer is wrong, guys. Take a try. Take a shot at it. Okay, what process is this? A foreground process or a background process?
Foreground process.
Thank you, Classy. It's a foreground process. What are foreground processes?
I think foreground process is when you install.
Yes, foreground process is when you install. And what are background processes?
Background process is the one that came already with the server.
Thank you. Thank you. Okay, cool. This process has a process ID because everything that runs in Linux, every process that uses CPU has a process ID. Everything that uses CPU on any system, Windows, Linux, has a process ID. This operating system or the system needs a way to be able to check who is doing what on the server. That tracking, the session has begun. We are currently in a session. Uptime. Our server has been up for 23 minutes. Sorry, for 23 minutes, but we have been logged in for how long? We have been logged in for how long now? We log in at this time. So we've been logging for 10 minutes, right? Because it's been up for 40 minutes. We're logging at this time. So we've been logging for 10 minutes. Now, this is how much CPU we're consuming, 0.02. So you can see that it needs to know everything that is running, every process. If you run a top command, you can see that the Apache process is running somewhere. You come up somewhere, EC2 right here, right? You see that's it. EC2-user has its own process. HTTPD has its own process, right? So let me cancel that. So everything has a process. So when you're looking for, if you do a PS command, you'll see that there's two processes, right? One is the system and one is you. One is the system and one is you. Only two major connections are on this server right now. Now I've installed many, right? We've installed more. We've installed this Apache server. So now we have to enable this Apache server. This next command, enable, is to make sure that whenever the server restarts or the server reboots or restarts, let's say the server restarts because it's doing a software update, whenever the server starts back up, Apache server should automatically start back up. So use system command to configure Apache web server to start at each system boot. Whenever the system server goes down and comes back up, Apache should come up automatically. Okay? So that's what we're going to enable. So we're going to copy this and enable it. So that's see, it created a SIM link in this directory. etc systemd system multi-user.target. This is the directory created in it, right? So interview question, if someone goes and delete this file, this http.service file, and the server goes down and comes back up, will the web server start automatically? Yes or no?
No.
No, right? Because they've deleted the file. This file is a physical file that has been edited and kept. You can do a cat, this file. Let's see, sudo cat. See, this file is a physical file that is on this server. So whenever the system is starting up, it will check all the system D. System D stands for system daemon. It will check all the system D files and say, oh, I have to also, as I'm bringing up all the processes, bringing up CPU, memory, disk, all these things, I have to also bring up Apache. Just mute yourself, Emma, you're yawning. It has to bring up Apache as well. So it will go look into this file because this file is in the same location as system D, right here, system D. It will look at everything under system D and it will bring up Apache. So right here it says, it wants Apache to start, it needs the service to start, right? After any network issues, it should bring it up to notify. So I'm showing you these things because in most systems, 95, 98% of systems in the world, MongoDB service, Kafka services, most services have this particular capability where when you install the service or the web server or application server or database server, you have the capability to enable it that if the server goes down and comes back up, let's say there's a network glitch or power failure, electricity failure goes down. When the server comes back up, it will go look into this directory, system D, and everything that has been set there to come up automatically, it will bring it up. So when we create databases, applications, we'll create this enablement to make sure that whenever a server reboots, the server comes back automatically. If it reboots and doesn't come out automatically, as SREs, what do? We come and check this file. We will start it up manually and we will check this file to make sure this file exists. If the file doesn't exist, what are we going to do? We're going to recreate this particular file, this file here. We're going to create it and we're going to pick enable so that the next time the server goes down, it will happen. This is an interview question for SREs. The system rebooted and came back up, but the website was still down. You just could not connect to the website. Why? Because the web server service never came back up because it wasn't enabled for auto restart. That's an interview question for SREs. Any questions there? Is that clear? Does that make that point clear? Yes? No? Okay. So we've enabled it. That's why I'm like, this tutorial is good for you guys to do because it will help you a lot. So enable, how can we verify that HTTP is on and it's enabled, right? It's enabled because people, you're working on several multiple engineers in the company. You can go enable something, someone go disable it. So you want to make sure it's enabled. You check using this command. Right there, it's enabled, right? Okay, cool. Now we have enabled the server. It wants us to open the EC2 console, choose instances, and go to security tab and open the security to the source, the world. So we're gonna go to EC2 security, and we have it open right there. TCP connection. So the TCP connection, right? Because we're trying to connect from client to server, right? Yes. Client to server is what? Client server is what? Client server is what protocol?
TCP.
Why server to server is what protocol?
UDP.
Thank you. I'll keep singing it every day. So this is TCP, right? Client server TCP. So you see here in the EC2 connection right here, it's TCP over this port numbers, this port right here. It's open to the world. So TCP protocol. Very rarely we use UDP unless you're doing a server to server connection, right? You see UDP protocol. Okay, cool. So the next thing is you can test your web server in the browser. There's no current disk. So we can take the IP address from here. Where is it? Copy this IP address and put it here to make sure that we have installed Apache. And that's it. It works, right? It works. So I've installed Apache. You see it works here. What else? So let's go back here. And the next step is so now we need to set some file permissions. This user that we're connected to this server, this user, EC2-user, needs to own the application files that we're about to create. Needs to own the web server files, right? So he needs to own Apache files, the Apache group, this user. Because we just installed it with him, doesn't mean that he owns it. This user installed Apache on the server, but doesn't mean he owns Apache, right? So in order for us to set the correct file permissions, we want to add this user to the Apache group so that this user can manage the Apache server going forward. So this is a command, user sudo user mode -a-g Apache this. This stands for group, right? This -a stands for add. You don't have to know all these specific commands, right? All you have to do is know where the commands are. I will never advise you to cram commands. Please do not cram commands like this. But you just have to know like the cd, the ls-ltr, those basic commands, right? Don't cram them. But you just need to know that, okay, this is the documentation. It's found in docs.amazon.com. That's where it's found. Docs.amazon.com. That's where it's found. Right. So sudo user mode -add -group Apache to this user. So we're going to copy that. It worked. Next step is to log out and then log back in again to pick up the new group. So when you add a user to a group in Linux, it will not take effect immediately. That user, this user, which we're just added into this group, he needs to log out of the server and log back into the server. Okay, before it can take effect. So here we have to exit. To log out, you type exit. So I'm exiting now. And to come back in, what am I going to do? Go back to the server and click on connect and connect. Excuse me. Boom. It's not connected. So now the next command now is run groups. To verify that we are part of that Apache group, verify our membership in the Apache group, we're going to copy these groups and just run groups. Why running group? Because we are connected as this user. How do you know? You can type who am I? And that's who you are, right? That's the user you use. That's the user you use to connect. So you can just paste that in there your EC2 user is part of the Apache group. Okay, cool. Now we want to change the ownership of the web server location. So every web server has this default location. When you install Apache, it comes with this default location. I'll show you here in this server. If you do an ls-ltr var, this is it, var, and then you have www right here. So if you do a ls-ltr/var/www, you see, it has HTML, it has CGI bin. These are the files that enable you to create a website. There's a little nice project here, this one, hosting a WordPress blog. If you guys want to do it as a group, you can, right? You can install a website and run some stuff here. It's pretty nice, right? To practice, but this is more for like DevOps stuff, not really for you, right? So these are files. I haven't changed my directory into this folder because I'm currently where? I'm still in my home. I'm still in EC2-user home. I'm just listing this directory. You can list the directory without changing your directory into that folder. I'm saying that this comes by default. Whenever we installed Apache, we did this HTTP install, this came with that installation. So the installation that we did up here, this installation, it created those files, created these files and directories for us. Okay? So now we want to, you see, it's owned by root. When it created these files, it's owned, the file is owned. The directories are owned. See, it's a directory because there's a D here. You see that? This D means the directory. The directory is owned by root. And what is root? Root is the most powerful user in the Linux system. Similar on the Windows machine, System32 is a powerful super admin on a Windows laptop. So you don't want to use the most powerful user on a system to control your website because only one or not many people are supposed to have access to root. So we want to change the ownership of these files to EC2-user, which EC2-user is the server user. That's the day-to-day user, day-to-day. You want to only keep root for system operations, not to be doing day-to-day operations because root is like a super powerful user. Root can delete their accounts, root can do anything, and it's like, I don't want to use it daily. So for security reasons, there's a saying in Linux or in the world that says, with great power comes great, with great power comes great responsibility, right? Yes. So you don't want to have roots. When you have root power, you can do a lot of damage or a lot of good. So for security, we're going to transfer ownership to this guy. So the next step is to sudo change ownership. Chown means change ownership. All these commands are here, guys. I'm not making it from nowhere, right here. Change ownership. Change the ownership of a file with chown command. We'll call it chown. Not, you call it chown. Change ownership. CH for change and then ownership. They're all here. All these commands are here. I'm not taking it from anywhere, right? If you practice these commands, all those commands in this, you're going to be a super person. Trust me. These commands, all of these commands here, if you practice them every day, you're going to be a superman or superwoman. I guarantee you. So sudo change ownership recursively, give that ownership to this user, to this EC2-user in this group. And what file are we giving it? What directory and files? Everything under var www. So change the ownership group of var and its content to the Apache group. That's what we're doing here. User and group. So that's what we're doing here. So that this user will be the one managing and owning the files going forward, no longer root. So we're going to copy that command and we're going to paste it here. And if you run this command again, you see that the owner has changed. The owner is now EC2-user and the group is now Apache. Before, the owner was root and the group was root. because we did the installation of this Apache using what? We used what? When we're installing it, we used sudo. And sudo is using root to install things, but you don't want root to own it. You use sudo to install things on the server, but you don't want root or sudo to own it. Think about that, right? Whenever you're installing software on your laptop, they ask you to put your password in. You put your password in, right? So that's what similar thing here. So now that this user and this group owns those files, now next we're going to add group write permissions to set the group ID on future subdirectories. Change the directory permissions of this and the subdirectory. So now everything under this var /var/www, we want to give permissions to this user to be able to write to that directory. And this is the command here. Change mode. Change mode. The mode is 2775. So in a Linux command cheat sheet, right here, 777 means read, write, execute. Let me talk about file permissions a little before I continue, because it's a very important thing that we need to know. So in Linux, you have read, you have write, you have execute. Okay? Read means you can read a file. You can open up the file, you can read the file. That's what read means. Okay? Like you can view a file, like how you open a file and view, that's what read means. Simple, very straightforward. Okay? Write means you can open a file and write in the file, like write some content in that file. That's what write means. Execute the file means the file is an executable, like you can run the file, like an application, for example, it's an executable, like the Apache web server. This command here, this one, this httpd start, this is an executable. It's a service. So it doesn't execute. Okay? So in Linux, read, write, execute is 777. This is the most powerful privilege you can give to anyone. They have the power to read, write, execute on any file. This is not best practice. This is frowned upon. This is not good. Okay? This is not good. Then the next one is 755 down. So this is read, write, and its permission to owner, and read execution permission to the group, right? So the next one down that you want is 7. So he can read. You can read. You can write. But here, you can execute. So 5 means you can execute. This is better. Okay? So in this one that we're doing here in our tutorial, we want to be able to write permissions. So before in IT, you cannot write if you cannot read. You have to be able to read before you can write. Yeah, it makes sense. Yeah, you have to read. If you cannot read, you cannot write. How about that? Yeah, right? So here, 2 is the first number, and then read, write, and then execute, right? So that's what we're doing. And then we're giving permission to this folder. This command here, and is to add another command on the same line. So let me put it here. Like this. So sudo change mode, tools, read, write, execute, right? And then that's one, this is one command. This is one command here. And another command. Find this, type, execute, and then another command. Sudo change mode this to this /. That means everything under this directory, change the mode to this. Read, write, but don't execute. Read, write, read, pretty much. Okay? So that's the command. And then we're going to hit enter. Okay? we'll go deeper into the file permissions in a later class, but that's what we're doing here. Then that's group write permissions. To add group write permissions recursively, change the file permissions of var and subdirectories. Now we want to just add permissions. This command here, this command that will just run up here. Now we want to find this folder. Type is a folder F, execute this sudo change mode, and have only write permissions for everything on the subdirectories. Here we're doing read and write. Here is just write for everything under this directory. You see here, this curly braces here. That's what we're doing. You barely do this stuff anyways, right? It's for DevOps people. And that's it. We're done with the web server part. Now we're going to the application itself. Create a PHP file in the Apache root. So instead of creating the file manually, we're going to just run this command. Echo means show. This is the code. And then this button means insert this code into this file. Usually, manually you will seed it into var www HTML like that, and go in there and create a file called php.info. But that's too much work. You can just copy all this command and just paste it like that. Okay. But first, I want to show you guys that if I do an ls/ltr var /HTML, right? HTML, right? There's nothing in this directory. It's empty. There's nothing in HTML. But the reason why we're creating the application file under HTML is because that's where, when you open up the application, the IP address of the browser, the domain name, that's where it will land. It will land in this location. This, right, this location here. It's empty, there's nothing in there. So now we're going to create this file, PHP info, and I'm going to put this code inside. This command, append, this command inserts this code into this file in this directory. If it's double quotes like this, let me show you. If you do it like this, if you do another one like this, it appends, like this, like this, it adds more files. It adds more code to the same file. But only one time, it inserts this one time. If you add it again, it keeps inserting this in the second line in this file. You keep running it, third line, fourth line, fifth line, sixth line. We'll do some more practice on this, okay? Let's just create the application and do some Linux troubleshooting on this. So the echo that, enter, and it created a file under this directory. So if you do an ls space -ltr, this right here, boom, that's your PHP info file. And who owns the file? EC2-user. In which group? Apache group. That means our permissions are working as expected because we change the ownership and we change the permissions, read-write permissions. So if you look here, it's read-write, read. It's read-write right here. This first dash is for D, the directory. It's the directory, D will appear here, like you see here. There was a D here. The second one is read-write for the user. Read, write, execute, but we did not put any execute. We just say left it empty. 5 was empty. And then read, write, execute. But here we only put 7 for read. Write is empty, execute is empty. And then same thing for the web. For everyone connected, they can only read this file. They cannot write to it. Only EC2 user can read and write to the file, which is what we just did. We just wrote to the file. That's the file. Okay. And that's it. We're done. In the web browser, type the URL of that file you just created. This URL is the public DNS address, instant followed by the /. So it's this public DNS right here on the EC2. This public DNS, copy that and put it there, /PHP info. HTTP. There you go. That's it. So this is just a page showing us that we have successfully installed PHP version 8.3.10 on this server. That's it. That's just it. We haven't created the application yet. We've just installed PHP and we've created that file. Okay. Now we're going to run to install the database and connect the database to that file before we can have a full-blown application. So the next command is sudo dnf list installed httpd MariaDB PHP MySQL applications. So run that. Yep, we have it's PHP Apache installed on this Amazon Linux. So next thing down here,
Can I see where you copied the
which one?
public IP DNS?
Yeah, right here. The public IP DNS, I copied it here. From the EC2 instance, select it. On the details, you copy it from here.
Okay.
Okay. This is it right here. So I copied this, I brought it here, and I put /PHP info. It says you should put where is it? /PHP info, PHP info.php. Copy that. /that. And that's it. You can see more information about PHP and everything that's, So this is the first step in creating a web server with PHP application on it, right? Next thing we want to do next. This thing is, IT is easy. It's just reading the documentation and doing it, right? I'm just reading the documentation and stuff and doing it, right? So we have done that. Now the next step is to remove the PHP info file. You should not have a functional server. If you add content to the Apache document root as this, you should not be able to view that content at the public DNS address below, right? So we're not going to remove this file for now. We're going to leave it in there. We're going to go now to so I've done the web server part. I've done the application part. Now I'm doing the database part, the last part. So now we're going to do sudo system start the database server. We're going to start the database server. Remember, like I said to you, everything, database, application, web server has a start and stop, right? Something has to run. So if the database is not running, you come and start the database. This is how you start the database. Start. Sudo system start MariaDB. So we're going to start the database. It takes a while to start. Databases take a while to start for some reason. That's it, just started. How do we check if it's running? How do we check if it's running? Sudo system, systl what?
Status HTTP.
No, status of the database. Everything that you want to check, it will be the database. If you're checking for the web HTTPD, for the web server status, you will use HTTPD. You check on database status, you do what? You use status MariaDB. If you're checking for on Oracle database, you use status Oracle DB. But the command is the same. Sudo system status, sudo system start, sudo system stop. It's always the same. Okay? But here we're doing MariaDB. It's running. Guess what? It has its own process ID. Is this a foreground process or a background process?
Foreground process.
Thank you. I don't know why others are not speaking in class there. I don't know why it's just one person speaking. I'm going to ask another question. How much memory is this database consuming?
Sixty-six.
66.2.
66.2.
Okay. Look at the status, the database status. Taking your SQL request now. So database is ready to accept connection from the application server. Database is ready. We've done the web layer, we've done the PHP application. Now then the database. The database is now ready to receive requests. Look at what it's saying here. Taking your SQL request now. You see that? It's ready. It's ready. So now we're going to run the MySQL secure installation. Because databases have user information, we have to always secure it. So we're going to run a secure installation of this security. So we're going to run this command. Security is very important when it comes to database because that's where user information is stored. So that's that. Type the current root password. By default, the root account does not have a password. So we're just going to press enter. We're going to follow the steps. Enter. And then type Y to set a password. And type a secure password twice. Okay, let's see. So we don't want to set the password now. Type Y to remove anonymous user accounts. So we're going to hit no here. Remove anonymous accounts. Yes. And then disable remote loop.
Give me tissue, please. Be fast.
Tolu, you're on. Mute yourself, guys. Please mute yourself, please. Disallow remote login. Yes. Remove test database and access to it. Yes. Why? Yes. Reload privilege tables now. Yes. Right. Why? Thanks for using MariaDB. So we'll set up the access, right? The next step is to optional. If you do not plan to use MariaDB server right away, stop it. You can restart it when you need it again. So you can stop the MariaDB, but once you use it right. So what are we going to do? We're going to go ahead and enable it. Remember, we always have to enable things because we want to make sure that when the server goes down and comes up, it comes up. So we're going to go ahead and enable this. So it's enabled. See, it created 3 symlinks. Where does it store the link? What does it store the enablement? System D. System D. HC System D. What is it? MariaDB service. What other service do you see? HTTPD service. When they call you and say database is down, go and restart it. What would you run? You will run sudo systemctl start database. But after you start it, what are you going to verify? Verify if it has been enabled to start on auto restart. Where is it? In this location. Okay, I'm saying it. If I were you, I'll write these things down. These are the things that you need to speak about in your interview. When they ask you in your interview, have you ever experienced any downtime issues? You say, yeah, oh, database went down. I had to log in and fix the issue. How did you fix the issue? Oh, I checked. I had to restart the database back. After you check, what did you do? Oh, I checked if it was enabled for auto restart. What did you check? Oh, I checked the systemd library. You have to be specific. I'm saying it now over and over. These files that restart the databases automatically are stored in systemd directory. Okay. You'll come in your interview, you'll be like, oh, Debo told me. Optionally, now we want to install PHP at my admin. We're done. We're done with database setup. Everything is done. But now for us to be able to use the application that we just created, right? We're done creating everything. We're done web layer, app layer, and database. But when you're done creating this, for us, the SREs, we're done. DevOps engineer is done. But for external users to be able to use it, like Isabel to be able to use it, we need to configure the my admin side of things, PHP my admin. So this is the steps to configure my admin so that it will appear like this, so that users can start logging into it, choose their language, and use the application. The DevOps engineers will tell you, oh, I'm done, oh, I'm done. Then now somebody, the admin, cloud engineer, web engineer, application developer will have to come and configure this my admin section so users can use it. Okay? So we're going to install the required dependencies to install my PHP admin. So we're going to install PHP PHP MB string, PHP XML-Y. So we're going to install that on this server and clear my screen. It's done. And then next thing is to sudo system. We're going to restart Apache because we just installed this new thing. Apache doesn't know about it. So we need to restart Apache so it picks it up, this new PHP dependency. So we're going to restart Apache. So let's see. If you run a status, guys, check this out. Pay attention right now. If you run a status, yeah, what's the process ID? 35877. Take note of this process ID. Kwasi, write it down. 35877 is the process ID for Apache. Okay? Yes?
Okay.
Okay. Now we're going to restart Apache. I want you to see something here. We're going to restart Apache process, the service. We're going to restart the service. Okay, now we're going to do a status again. Let's see what the process ID was. What was that? 38947. What was the old process ID?
35877.
So why did the process ID change?
Because you restart the server.
So what does that mean? Of course, that's why it changed. But what does that mean? What does that mean? Why did it change?
Because it can be moved to another location where the server is.
No,
To
no,
another server.
no. That's Isabel, you're referring to when you restart the server. We did not restart the server. We started the Apache process, the Apache service. On this server, we have a web server service called Apache, which is HTTPD. All we did was started the service, not the server. We didn't restart the EC2 server. No. When we start the EC2 server, the IP address will change because it goes to another location, another zone, another host. We started a simple process within the same server. It's the same server. Why did the process ID change?
Is it because you started a new session?
Close. Okay, let's say you're at Walmart and there's 10 parking lots. Parking lot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You go to Walmart at 10:30 a.m. You park in parking lot number 2. You go shop, you come, you leave. You forgot to buy vegetable oil. You go back to Walmart. Parking lot number 2 is taken. You park in parking lot number 5. So what's your parking lot number? Or the better question is, why did your parking lot number change?
Because you left and somebody else took the place.
Thank you. So why did the process ID change?
Because we turn off the service.
Yes.
Because when you okay. No.
Yeah. You turn off the service and you started it up. So it came back up, it acquired a different
The
process
new
ID.
process ID. Okay. Yeah.
Thank you.
Okay.
Yes. It acquired a new process ID because the old process ID cannot be reused again. It's dead. That's it. When you stop a process and you start it up, it acquires a new ID because the old ID is dead. You can never go back to that process ID ever again. It's going to give you a new process ID. If we do a stop and start again, it will change again. Let's do another restart again. It stops it, restart, stops it, and start it. Some funny guys will ask you in an interview, what's the difference between a restart and a stop? I'm like, why would you ask that kind of question? Who wants to answer? What's the difference between a restart and a stop? Do you guys ever stop your TV or you turn it off or you restart it or your laptop? Which one do you guys do?
You turn it off.
Okay, when you turn it on, what happens? It comes on, right?
Comes on. Yep.
Is that a restart?
No, it's a start.
So when you turn your TV off and on, is that a restart or is that a stop and start?
Stop and start.
Okay, so what is a restart?
That does not make sense. A restart is like maybe it's already on, but maybe let's say like internet went off or lights went off and it's restarting, but it still goes off, right?
Okay, the difference between a restart.
Is it the restart where you're actually bringing back up the applications that were running?
Very simple. It's very simple, guys. It's very simple. You're making it complicated. A restart is simply a stop and a start in one command. That's it. Right here. Restart. It will shut down my laptop and start it up. That's it. Simple. You're making it complicated, guys. A restart is simply a stop and a start. That's it. Whereas a start is starting from a brand new file. A start is just starting the process from scratch. And a stop stops it and nothing is running. I was asked that question in an interview and I was sweating, like, why are they asking me this kind of question? Like, it's just weird. Have you ever been in an interview and you forget to spell your name? Like you're panicking and you forget to spell your name. You don't even know what your name is. Like you're zoned out. That might happen, guys. So a restart is simply a stop and a start. And then a start is just starting the server from the service from scratch. And a stop just stops the service. If you run a sudo, let's do this again. Let's do this. If you run a status, you have a new process ID, 39262. If you run a stop, it stops the process. If you run a status, look at that. 39262. It stopped. If you run a start, it starts. If you run a status again, what is that? 39649. So whenever you stop a process, that process ID is dead. Whenever you start it, it comes up with a new process ID. You see? 39262, 39649. Now, we talked about something a long time ago called zombie processes. What is a zombie process? What's a
I think you say that is a process. You kill it and come back again.
There you go, Kwasi. A zombie
That's what
process is a process that you. Sorry?
That was what I was referring to when you asked the restart question, was a zombie process.
Yeah, no, a zombie process is the one that you kill. It does, and you do a kill, like 39262, 39262, like that. And they say it's dead now. If you do a sudo kill, and it said no such process, but it will come back. Let's kill this process. Let's do a sudo 39262. 649. Oh, sudo kill. Sorry. We'll kill that process. So we'll do a status. Process is inactive. It's dead. We killed it, right? So this process, HTTP is not a zombie process. That process where you do a kill and you status and it's still there, right? So now let's do a start again. And then status again. And we have a 39914. It's only going up. It's only going up and up and up and up. Okay, cool. So I'm happy we've gone to that process services. So we're going to restart. Now we want to make sure we restart PHP as well, which is the application. So we did restart, we did enable, let's restart PHP, the application. So PHP, the application up here, right? This PHP application can pick up this new PHP admin so that when the application comes up, it picks up the web server, picks up the application and everything. So we're also going to restart this as well, right? So copy that and run that. So sudo systemctl is a system control. The system control application for the system that controls all the processes that run within the system. So whenever you want to start something, it will be sudo systemctl, or stop something with systemctl, restart, status, stop. It's all under systemctl. It's called system control. Okay, and then now we can now go into this directory. I'm just gonna copy it. I can go there. I'm just gonna go. So now we're in this directory, and if you look here, you have that PHP info file still there. I didn't delete it. And now it says select a source package for the latest PHP release, right? To download. So if you go to this link here, you can select a source package. So we're just gonna take this most recent one. phpMyAdmin 5.2.1 all languages.zip. Let's see. .tar actually. So let's make this command somewhere. I'm gonna make this command. So I'm gonna copy this and make the command before I paste it. So come on. This is a VS Code. I use it for putting. You don't need to have VS Code. That's right. New. So let me just use this. So it's this right here, .tar.gz. This one. This one. I'm gonna take this one. So I'm gonna just copy the link. I want to do, sorry, wget, and here's the link, right? You see that? w.html, the file downloads, right? So that's what I want to download on this system. So I'm gonna go with that and then run that. Okay. It's downloading it. So this wget that we install is what you can use to download packages directly from the internet to this server. To do this, that's the package you downloaded, right? phpMyAdmin 5.2.1, all languages. All languages means English, French, Spanish, everything is in there. Now we want to make a directory. We want to make a directory, phpMyAdmin, and also unzip that file, because the file is gzip, right? Unzip. So unzip in Linux is *-xvzf, right? So again, I'm going to make the command. I'm going to copy this and come here and make the command before I run it. So right here, this one. That's the file name. And this is the file name here. This is the file name. Copy that. Put it in there. Make sure there's no spaces. And then we're going to copy that. So you see, oh, we're going to just make the direction all in one command, right?
Laptop.
Go ahead, because Isabel was a question. So now we're installing phpMyAdmin on this server. Isabel, what's your question? And next, I'm going to remove it. And then we're going to start MariaDB. Then we're going to have our application. And that's it. We're done. And then you guys are able to connect to it. That's it. So it's done. Share my screen. ls-ltr. That's the application. You see? phpMyAdmin is the application. This application that you see here. This application that you see here, this thing, this is it here. Why? It's a directory, it's read, write, executable, it's read, and then it's also executable for everyone. So this is an executable file. Let's feed it into PHP. And then -ltr. You have all these files. All these files, vendor, doc, template, logo, theme, setup, is what, when you log into the application, you're able to see all these things. This is what allows you to see things on the application. So you'll see that. Okay, let me go back one. So I'm currently here. So pwd, I'm currently in the application directory. That's right there. So play that. Next command is to delete this download file. We don't need it anymore, right? So we're going to remove it. You see how they do, just do rm and remove? You don't do rm-rf, right? You just do rm. Don't do rm-star. Rm the file name. So we're going to do rm the file name. So here, come in here, make sure you list the files first, and then you do rm, then the file name. You can start typing PHP, hit enter, or hit tab on your keyboard. PHP my admin dash. You hit tab on your keyboard and it auto completes it. You remove that. The file's gone. So now we have just phpMyAdmin or PHP info. And now we can now start the Maria database server. You can do a status to check that it started. I always do a status, all right? It's running on this process ID, right? That's it. And that's it. Our application is up and running now. So now we're going to take HTTP, our public DNS name, /phpMyAdmin. And that's the application. Let me make the command down here. So our public DNS name is the domain name from AWS. This is it here in EC2. This one, public IPv4 DNS, that's it. Copy that. And put it here. /phpMyAdmin, and that's the command. And that's it. You can change languages. You can do English, United Kingdom, and you can now log in. You can do roots. And I don't think we created a password. We didn't create a password, but that's pretty much the application. So I'm going to give you guys the link in the chat, and you can look at it. Click on it and see if you can connect to it. Okay. But we didn't create any kind of username or password for it, right? Because when we're creating it, we disabled remote login and all that stuff here. Remember? We disabled remote login and all this stuff here. Disable remote login right here. So, right. If I wanted to create login, I'll create a password here for root and I'll be able to log in. But I didn't want to, right? So that's pretty much it. That's it. So application is working. So now the network team will take this domain and customize it behind the actual company domain, right?
Ralph, where's your Ralph?
Full is still waiting. Full is still waiting.
Quasi, mute yourself, man. Mute yourself. Mute yourself, Quasi, please. Guys. These videos. That's why sometimes I just mute the whole class. So the behind this domain name is this URL. So when users try to go to accesstarget.com, they're actually hitting this domain name. You see that? That's why most companies, most companies have a different load balancer or different behind their main domain name. You're never gonna hit their servers directly. When you hit the domain name, it routes you to this, and then this connects to this web server. Are you guys able to open the application?
Yes.
Yes.
Yeah.
Any questions on what we just did?
So in the mostly like in a real job,
Yeah.
this is just the kind of application that you're going to see, right? You have to
Let me create a password and username so you guys can connect to it. Let me do that. 1 second. So I'm going to run this MySQL installation again. I'm going to run it again so that you guys can connect to the application. Let's do that. So I'm going to run this. Enter current password for roots. Okay. Switch to socket authentication. Yes. Change the root password. Yes. So new password. I'm going to do capital P, password, 1, 2, 3. Capital P, ASSWORD, 1, 2, 3. Okay. Remove anonymous users. No. Disallow remote login? No. Remove test database and access to it? No. Reload privileges tables now? Yes. That's it. So now I'm gonna go restart. Where is it? Stop MariaDB and rerun it again. And then start it up again. Okay. Now you refresh this application. Let's see if we can connect. Root. And then password 1, 2, 3. That's it. Boom. Connected. How cool is that? The password is password 1, 2, 3. Password 1, 2, 3. The username is root. Try to connect to it. Let's see. Just refresh your browser and try to connect to it. That's it. And that's it, guys. You're connected to a PHP mining application. You can see all the data, tables, all these things that you just built. Okay. Now, if this application goes down, you have to troubleshoot it, but you have to be able to run this sudo system, start, restart, all these things. That's all your job. You have the easy part, right? You have the easy part. You come in here, you run a top command. What process is consuming the most CPU, right? You see Apache. Which one do you kill? Which one is, you see, PHP application is running. It's consuming 1.7 CPU. Let's go look at the monitoring dashboard. We'll go to monitoring and we'll see this dashboard, right? You see CPU is at what? 2.67. It's gone up. Network bytes went up, but it came down. Network out from the server going out, it went up. It's still up. It hasn't come down. Packets in went up and it came down. You see that? So let's go completely to let's do, no, I don't want to enable daytime running. It's expensive. But you can see here you have CPU credits. In the beginning, the CPU consumption was high. Now it has dropped, now it's flat. Our credit CPU balance was low. Now it has gone up, means we have a more balance now. So these are the kind of things you'll be looking at. Okay. As far as storage is concerned, look at the storage. We'll have 20 gigabytes. Look at the read or read throughput. What's throughput? Throughput is the amount of time it takes for a process to go to disk, read data, and respond back, right? That's read throughput, amount of time it takes to go to disk and read the data and respond, bring back. What's write throughput? The amount of time it takes to write to disk. That's write throughput. Throughput is the ability to, like, if you have an opener to open your beer, that's throughput. Throughput is a metric that you use to calculate the time it takes to perform something. So a read throughput is the time it takes to read data from disk. A write throughput is the time it takes to write to disk. That means that when you write on your computer, how long does it take when you hit save? How long does it take to save it to disk? Latency, I think these are key. These are things that I should add. I think I have a terminology that you're going to take home. Latency, throughput. I think this is research. Latency is the amount of time it takes to send a request and get a response. That's latency. Where is it? Latency right here. So read latency is the amount of time it takes to send a read request and get a response back. That's read latency. You see, because we're doing a lot of installation on the server, it's gone up, come down, gone up, come down. So if you look at your read latency on your servers, this is normal because there's activity on the server. So this is normal. So the average write latency, because we're installing things in that server, that means we're writing to the server. It goes up and it's going down. If you see more write up, means people are doing things on the server. Look at the read throughput. It was high and now it's come down. So when you look at read latency and you look at read throughput and you look at this time here, what is this? This was 135 UTC. You come here. What was that? 130 UTC. It correlates. Read latency and read throughput around the same time. It correlates. So it's normal. This is how you look at things in the job, guys. This is real life. I remember you asked me in real life, what would you do? This is what you do. The application is running fine. Users are using the application. That Connect is running fine. You don't have any issues. You just monitor. This is what you're looking day to day on the job. This is where you come to work in the morning, you're looking at these things. If you get a complaint that, oh, the reads are slow, you come and look at read latency and read throughput. What's read latency? It's the amount of time it takes to send a read request and get a read response back. What's read throughput? That amount of time it takes to read something. So if this goes up, you will know. If it goes up high, if it keeps going up and up, you're going to look at it. I'll look at the time. Okay, that's 135 UTC. You go back, look at the time here. 135 UTC, latency went up, throughput went down. You do your calculations. Why did latency go up? Latency is the amount of time it takes to send a request and get a response. That's total turnaround time. Send a request, get a response. That's read latency. Throughput, the amount of time it takes to read from disk. So throughput is almost similar to latency. Similar. So you have to calculate. Okay, look at them. It's okay. It was 1 here at 135 UTC is high. And then here, it's 1.65 throughput. So this is the kilobytes per second. How many kilobytes were you able to read per second? That's what read throughput is. The amount of data you can read per second. That's what throughput is. Sorry, I forgot. So throughput is data per second, and then latency is milliseconds per operation. How much time it takes to send a request and get a response. While throughput is how much data you can read from disk. Is that clear? I think that's, yeah. So throughput is how much data you can read. Read throughput is how much data you can read from disk in how much time. While write throughput is how much data you can write to disk in how much time. While read latency is how many seconds it takes to read from disk. And while write latency is how many seconds it takes to write from disk. So latency is time, while throughput is data. That's it. Very easy. So you look at those two metrics, read latency and read throughput, write latency and write throughput, and you compare it to make sure everything is. If the issue is read, you're looking at what this is under storage. This is under storage, by the way, right? This is storage metrics. So if the issue is disk, you look at this first. And then when you couldn't figure it out here, you now go on the server. And what do? You start running the things for disk right here. You start running your du-ah and those things, right? These commands. So the first step is the dashboard. First step is always in the dashboard. If you can't figure it out here, then you now go on the server and start running df-h. Oh, but there's enough space here. There's 18 gigabytes available. You run a do-ah. Start looking at the files. Oh, I didn't mean to run that. That's too many things. You can kill that. Yeah, Control C. Right. So then you look at the commands that you have available. Or what I said in the beginning of class, where is it? This performance checklist. If there's a disk issue, what do? This is the thing. You run an IO-stat command on here. And you look at, okay, this is IO-stat, average CPU consumption device. Let's see. This is advanced stuff. Okay. This is advanced stuff. This is when you really cannot figure it out by looking at the dashboard, then you start going that deep and looking at these numbers and stuff. But you work in a team. So you're running this stuff not just to look at it alone, but you're saying, guys, I see that there is 98.04 idle percentage of CPU on that device. You communicate this information out, right? And then the next command is vm-stat. This is for memory, right? And you see right there, okay, I don't see any issues. There's enough free memory here. Look at that, free. It's a lot of free memory. So you can cancel that. So you're just running your checklist. This is just a checklist. df-h, our file system's nearly full, right? df-h. Because they can say, oh, we don't have enough space. You say, no, guys, I run it, there's space. We have enough space on this mount point, xvda1. So enough space on there, right? There's enough space in the temp as well. So the system can write to this directory. The system directories have enough space too. They have 4 megabyte here, 2 megabyte here, 781 here. So the system has enough space as well. Because sometimes systems will not have space to write, and so it will cause issues. But there's enough memory space available for everybody to write. Then you go run the next one now. X is slower, -10, right? Or not found. So it's not available for this because we don't have an ext type disk here. So let's try BIOS slower. Not found. So every system has its own command. Here we can do a cat, I will count. If there are any errors, you will show that there are no errors in that server. So these are the main commands that you will run to do performance analysis. You do an uptime on this server. Uptime. You see the uptime is 1 hour, 50 seconds. One user load average is 000, right? That's it, guys. That's the job, right? What else is important here that you need to run? Peak stat one. So per process, you only see how much CPU one process is consuming. That's it. This is a good one. Peak stat. you see Apache is consuming 1 CPU by itself. And that's the process ID for Apache. That's the UUID. You can kill that now. You can say, okay, guys, you see Apache is using 1 CPU alone, right? And just system D, right? And nothing else is using CPU. So we should be good. You see that? Okay, cool. I'm going to give you guys all these links. Should I just email them to you, all these links? Does that better? Even this one? That says what happens when you type this in the browser, all of them. Okay, I'll put it in the email to you guys. Okay. So that's that. That's how you troubleshoot these things. You can see that of generated activity, there's read operations, write operations. So you're looking at these things. But again, we'll go more into more details as we keep going. But I wanted to just let you guys know that this is what you're getting yourself into is applications will be running day to day, and all your job is to look at these graphs. You're a monitoring person, right? Time spent idle percentage, 100. If users are saying, oh, I'll send my request, but it's queuing, you go look at the queue length, and you see the queue length is high here. That means that people are waiting to do stuff on the server. Their processes are hanging, but it has come down now. So when they say we need to define an SLA or SLI and SLO, SLA stands for Service Level Agreement, SLI stands for Service Level Indicator, SLO stands for Service Level Objectives. It's saying that which of these metrics are okay. For example, if queue length is at this level, it's too high. That means it's not okay. So a service level indicator or service level objective for us will be down here. This is okay. If it's here, it's fine. If it's here, it's abnormal. If it's here, it's abnormal. If it's here or here, this range, it's fine. This is our service level objective. So we'll go dive into those things and get to bed. You need to understand all these metrics. These are called metrics. Metrics are just a key performance indicator that we use to measure the performance of our system. Okay. Now we're in storage. We can go to networking, monitoring, and you can look at CPU utilization and these other metrics. Any questions? You can look at more metrics here. Status check, failed, all these other metrics.
I have a question. The other day, if I remember well, you told us that sometimes in some company we might not have access to this console platform. How are we going to see the metrics of all the instances?
There's a service called CloudWatch, monitor resources and applications to service. So you may not have access to the console, but you may have access to this. You have to have access to something, right? To something that you can see, right? So here, all metrics, EC2. My network is slow. Come on. Slow. Right there, boom. You have access to this, right? You only have access to your job, something called job role. If you're a cloud SRE engineer, you will have access to what cloud SRE engineers do, which is monitor. You will not have access to EC2 to be installing things like this, but you have access to go and run these commands on that server. You may not be able to go to EC2 and create an EC2 instance, but you have access to connect to one and run commands. Does that make sense? So they'll give you access to your job role. When you join a company, there's different roles and permission sets. They'll add you to the group Cloud SRE group. And those people have access to monitor systems using CloudWatch. There are other tools that we're going to learn though, right? So you may not even have access to AWS, but you're going to have access to Prometheus monitoring. Prometheus monitoring. You're gonna have access to this application that I'm gonna create. Prometheus monitoring. It's a different, completely different monitoring tool. We're gonna do Grafana. Grafana dashboard. Completely different tool, separate from AWS. I'm gonna create a Grafana dashboard, connect it to an application. Same thing for Prometheus. Prometheus and Grafana work together. So Grafana collects metrics on the system and pushes the metrics to Grafana dashboard. So this is the dashboarding system, while Prometheus is the monitoring system. So Prometheus pushes information, collects logs from the application servers, web server, database servers, and pushes it to a Grafana dashboard. So in the morning, this is what you'll be looking at every day. The dashboard like this, Grafana dashboard. You see all these metrics. So yes, you may not have access to AWS at all, to even log into AWS at all, but you have access to Prometheus and Grafana. Okay. Were you guys able to?
I have a question. Are you going to teach us monitoring since that's what we're going to be working on?
Oh, yeah, that's the main thing. Oh, yeah. Oh, hell yeah. That's the main thing. We're doing the fundamentals now of networking and security because in monitoring, you need to understand networking, right? You need to understand, look at this. You need to understand what happens, why there's network averages, this client server relationship, all those things, network in packets, right? This is the main thing. This is the meat and potatoes of your day-to-day job. It's here in the interview, right? You're going to do it. Yes, we're going to do it. Oh, yes, you're going to do it. Right here. Networking, the basics. Right here. Monitoring. Where is it? Right here.
Okay.
That's the main thing. But look at that. Prometheus. We're going to learn Prometheus, guys. We have to. There's no way. You have to learn Prometheus. We look at a job. Cloud side reliability engineer job. They're asking for Prometheus. I guarantee you they're asking for it. Look at this job. They're asking for Splunk. They're asking for GCP or AWS. If you have both,
Splunk is a business intelligence tool, right?
no, Splunk is a monitoring tool. Guys, I want to give you guys a little hint. Learn to Google stuff. Anything that you doubt, Google it. Google has the answer. Okay? Look at this job. What are they asking for? Kubernetes, microservices, MongoDB, RabbitMQ, MySQL. Yes, monitoring platforms. Look at that. Microsoft Azure Cloud, Google Cloud Platform. Look at that. So it makes sense that we're learning all right. We're learning both of them. Oh, Microsoft can hire you too. Microsoft and Irving can hire you too as a cyber reliability engineer. They actually pay well. I was surprised at how much they're paying. They'll pay you and they'll hire and they'll train you actually because they have something called due diligence. They don't believe that you know what you know that you told them. So they have to train you and be sure that you know before they put you in front of their customers. They don't play around. Apple also hires cyber reliability engineers. Apple pays a lot of money for these guys. They don't do nothing. The job is very, very easy at Apple. Look at that. 10th of October, 2024. What are they doing? SRE manager. Leading a team of responsible providing performance. Look, this is a very, very basic job, I'm telling you. You're just a manager. Look at that. You're a manager. Rackspace is hiring as well. Man, there's just so many jobs, man. Wow. Look at that. AWS, Azure, or GCP. You see, every job is asking for at least 2 clouds. So why wouldn't you learn all? MongoDB is hiring. Senior site reliability engineer. Look at that. Amazon, Google Cloud, or Microsoft Azure. Experience with at least one of the major cloud providers. OS performance tuning. Experience in networking. Look at that. HTTP, TLS, DNS. Linux environment. information security issues, like everything that we've been teaching in class, the job is asking for, right? Here, you're going to be on call, weekly on-call rotation, right? So we're on track, guys. Kansas asking for children, class high reliability engineer. Look at that. AWS, Azure, GCP. It's a common thing. You have to know at least 2 guys, right? Look at that. Automate additional routine processes, global payments. So it's the same thing. Over and over, it's the same thing. Tails is a train. This is a company that makes trains in the UK and then the US. Microsoft Azure. So if I don't teach Microsoft Azure, do you have a chance? I have to teach all 3 clouds. I have to. EPAM system. This one is specific. This one is AWS site reliability engineer, right? What are they asking for? Look at that. Similar things. Collaborate with team members, improve CI/CD processes, implement monitoring practices. See, monitoring, performance, maintainability. You're just maintaining. You don't develop any, you're just maintaining. Let's look at one more. Oh, that one. Geico. Is this Geico? Senior manager, site reliability engineering. Wow. 110 to $261,000. Wow. 8 years leading. This is for a manager. But the manager must know AWS, GCP, and Azure as well.
Take a kind of job, they cut your head.
Senior site reliability engineer, 140 to 160. This is a very bad salary range because this salary right here, if they give you 160, you're in a different tax bracket. You're paying 32% or you're paying 28% in taxes. If someone making 140, is paying 24% in taxes. So if I were you, I would say give me 149,900. So you stay under 150. You know what I mean? That extra 10,000 doesn't mean anything because you're going to be in a different tax bracket. Because if you make above 150, you fall in a 28% tax bracket. If you make above 205, you fall in a 32% tax bracket. If you make above 650 or above 400,000, which is above what the president makes, you fall in a 36% tax bracket. So be careful when you choose a salary. Okay, very careful of that. You don't want to make. If you're gonna make above 150, make 199.9, 199.999. You know, stay under the next tax bracket level. Look at this one. SRE DevOps. Similar ask here. Reliability. So we're good. So we're gonna start doing a lot of monitoring, right? 4 years of AWS, Jira, monitoring, dashboarding. Look at that. Dashboarding is a big one. Look at that. Grafana, AWS, Azure. Grafana is big. So we're going to do that. We're going to do it. We're going to do Prometheus. We're going to do more processes. We're going to do resume. We're going to do interviews, right? So we're going to do a lot of, we're going to do Prometheus. In here, it's Grafana as well. We're going to do monitoring, implementing SLOs. This is how you create SLOs, right? Service level objectives, how you look at them, right? Number of successful requests that comes in, request that goes out, right? You're going to calculate SLI, you can do some calculations on that. So we're going to get busy, guys. We're going to get busy, okay? All right, we're done. I was going to create a Google Cloud account. Sorry, Google Cloud VM. So here's my Google Cloud accounts right here. Welcome to Google Cloud. This is my account. And I want to create, I'm going to go here. I'll click here. I want to create, go to the dashboard. So this is the Google Cloud dashboard. My friends left AWS and went to Google Cloud and built this, but it's trash, right? So you can create a monitoring dashboard and It's very, very basic cloud. It's the most basic cloud ever. AWS is complex, followed by Azure. Azure is not very basic. Azure is okay. The AWS is complex, right? It's the most sophisticated cloud that ever existed. This is Azure. Very, very simple, right? This is the dashboard. Very basic. You see that? Look at AWS. Very, very well, it's basic, but they made it this way, but you used to look a lot. Look at that. So many things involved, right? So now it looks like this. That's my monthly cost of my application that I run on there, everything, right? So, but Azure is very basic, very, very basic. And then Google Cloud is where's Google Cloud? I just had it open. Sorry. Right here. So I'm gonna create a virtual machine. So all I have to do is go to up here and just do virtual machine. What's right there? Compute engine. It's called compute engine. And you have to enable the API. So Google is all about APIs. API stands for application programming interface. You have to enable it. I've enabled billing. Come on now. Cannot enable it because all your billing accounts are closed. Guys, give me 1 second here. This is what happens when you enable API, same thing again. I think it needs 24 hours to it needs 24